put u equals to cos s, the u over the s is equals to sin s. The s is equals to minus the u over sin s. The integral of cos squared s sin s, the s is equals to minus the integral of u squared sin s times the u over sin s, which is equals to minus the integral of u squared du, which is equals to minus u raised to power 3 over 3 plus c, which now give us minus cos raised to power 3s over 3 plus c. Question 32. Evaluate the integral of sin raised to power 3s ds. Solution. Integral of sin raised to power 3s ds is equal to or the same thing as integral of sin squared s times sin s ds. We have not changed anything. Therefore, in the law of trigonometry, sin squared s is equal to 1 minus cos squared s. So we now have the equals to the integral of, if you substitute the equivalence of sin squared s, which is 1 minus cos squared s sin s ds. Then if you now open the bracket, we now have the integral of sin s minus sin squared s sin s ds. Then if we now if we are doing our integral, we now have, if you do the mathematics, we now have minus cos s plus cos raised to power 3s over 3 plus c. Question 33. Evaluate the integral of cos raised to power 3s ds. Solution. The integral of cos raised to power 3s ds is the same thing as the integral of cos squared s times cos s ds, which is equals to, if we now, according to the law of trigonometry, one of the law of trigonometry, we have that cos squared s is equals to 1 minus sin squared s. We now have the integral of 1 minus sin squared s cos s ds. That is, we have not still changed anything, which is equals to the integral of, if you open the bracket, we now have cos s minus sin squared s cos s ds. Then if you do the integral, we now have sin s minus sin raised to power 3s over 3 plus c. Integration by parts. Let u and v be functions of s. We recall from the product rule that the uv over the s is equals to u, the v over the s plus v, the u over the s. Therefore, the integral of the uv ds over the s is equals to the integral of u times the v times the s over the s plus integral of v times the u times the s over the s. If you make the uv the subject of the formula, we now have, and cancel what the like terms, we now have integral of uv is equals to integral of u dv plus integral of v du. If you now make the integral of v du the subject of the formula, you now have uv minus the integral of u dv. Question 34. Evaluate the integral of s sine s ds. Solution. If we put v equals to s and du equals to sine s ds, then the differentiation of the v over the s is equals to 1. Therefore, the v is equals to the s, and the integral of the u is equals to minus cos x. Therefore, if you substitute the values into this formula, the integral of v du is equals to uv minus the integral of u dv. We now have the integral of s sine s ds is equals to minus s times cos s plus the integral of cos s ds. Therefore, we now have minus s cos s plus sine s plus c. Question 35. Evaluate the integral of s exponential s ds. Solution. Put v equals to s, du equals to exponential s ds. Then, if we do the differentiation of s, we have the v over the s is equals to 1. Therefore, the v is equals to the s. The u, if we do the integration of the u equals to exponential s ds, we have u equals to exponential s. From the formula, integral of v du equals to uv minus integral of u dv. We now substitute the value into this formula. We now have integral of s exponential s ds is equals to v is s and our u is exponential s minus integral of our u is exponential s times our dv is equals to ds, which we now have s exponential s minus the integral of exponential s is exponential s plus c. If we bring out the like terms out of the bracket, we now have in bracket s minus 1 exponential s plus c. Question 36. Evaluate integral of s log to the base a s ds. Solution. Put v equals to log to the base ex and du is equals to x ds. The v over the s is equals to 1 over x. Therefore, the v is equals to the s over x. U is equals to s squared, that is the integration of the u equals to s ds is u equals to s squared over 2. From the formula, integral of v du is equals to uv minus integral of u dv. If you substitute the value into this formula, we put our integral of v, which is log to the base as, times our v is 1 over s ds, which equals to our u is s squared over 2 times our v is log to the base s minus integral of s squared over 2, that is for u, times the v, which is the s over x, which we now have. If we do our